One thing that flat earthers can't seem to stop talking about is experimental methods. And with that, I mean that they mainly seek to discredit any experiment that shows that their model is batshit crazy. And they try to do this by talking absolute rubbish about independent and dependent variables. Now, it usually comes down to a failure to understand either the experiment, the hypothesis, or most likely a failure to understand any concept in science or the philosophy of science. Of course, we need to add a few more ingredients, mainly the arrogance manifesting itself as the Dunning-Kruger effect and a generous dose of bile, which, when all mixed together and baked in a hot-headed oven, it creates a fresh fluff. A good quality fluff will have such a strong and misguided sense of self-assurance that they outright reject the notion that there is a possibility that they may have misunderstood something. One of the key things they commonly misunderstand is the concept of independent and dependent variables. If I'm honest, I am actually still unsure about what Fluffs use as the definition of the IV or the DV. But I have a sneaky feeling that their definition is both horribly specific but also really fluid, so they can bend their definition to be something along the lines of something very specific and with a bullshit caveat which allows us to pretend to discredit your statements so my subscribers give me lots of super chat money. Oh, and you're a retard. The definition of the IV is actually quite loose. It really just means the thing that, when changed, results in a change in the dependent variable. One particular one I like is a quantity that provides context for the change in another quantity. In the simplest form, we can express a relationship mathematically as y is equal to f of x, where y is the dependent variable and it is a function of x, which is the independent variable. Let's take a simple straight line equation, y is equal to mx plus c, where it is really obvious what is what. X is the IV and y is the dv, and m and c are parameters. Of course, m and c could also be an independent variable, but we usually denote the IV with the symbol x. Note that I use the word usually, because we could rearrange this equation to give x is equal to y minus c over m. Now, is x still the independent variable? The statement is actually exactly the same, but it is now being formulated in terms of x being the dependent variable. Hell, we could rearrange it however we want. But let's take this into a physics experiment. Here it would be easy to say that the independent variable is the bit that you directly manipulate and the dependent variable is the bit that you measure directly. And if this were the case, then you would have a rather elegant experiment. A common misconception within the flat earth community is the idea that the IV is the bit that you physically change and the dependent variable is something that you directly measure. But let's kick this up a level of complexity and consider this setup. This is called a magneto-optical Kerr effect system, or more commonly known as MOKE. We can use this system for a large number of experiments to probe the magnetic configuration of a sample. It is quite a complicated setup, but it does nicely demonstrate the ridiculousness of the flat earther requirements. MOKE is the phenomenon that when polarized light hits a magnetized surface, the polarization of the reflected light is changed according to how the surface is magnetized. So what we have here are two polarizers through which we pass a laser. The first only allows light through which is polarized along one axis, let's say up or down. And the second one only allows light which is polarized orthogonally, let's say left or right. So in a reference state, no light comes through the second polarizer, but when a laser is bounced off a magnetic sample, the polarization is rotated a bit and some light may pass through. Now on the sample side, we have a sample mounted between two electromagnets and we pass a current through these magnets to create a magnetic field that changes over time. This changes the magnetization, which we can then measure. Intuitively, you would say that the independent variable in this setup is the magnetic field and the dependent variable is the magnetization. But according to Fluff logic, you would be wrong. The dV would actually be the intensity of the light passing through the second polarizer, and the IV is the current passed through the coils, or to take it to the extreme, the resistance of the circuit. Now, if we are really nitpicking, we could say that the only thing we are physically manipulating is the position of the slider on a potentiometer. You see, This strict definition of the independent variable is absolutely useless. We know exactly how the current passing through the circuits affect the magnetic field, and we know exactly how the polarization of the light relates to magnetization. We can calibrate our equipment to figure out how the field relates to the current, or even better, we just measure the field. And this is an important point. In an experiment, your independent variable could just be something that you measure. In fact, you have to measure it because otherwise you wouldn't know what it is. This is independent of whether you are physically manipulating it directly or indirectly. But let's take this up a step in complexity because physics is really easy. Let's take a look at psychology, where we rarely have physical control over the independent variable. Most psychological studies are observational in nature. You gather as much data about as many observables as possible, and your experiment actually happens in the analysis stage. And this is why I like the definition of an independent variable being a quantity that provides context for a change in another quantity. Because when you do your actual experiment in statistical sciences like psychology, you can make any of the measurables your independent variable, and you just plot your dependent variable against that. You perform a suitable statistical test, and hey presto, you can figure out what the relationship is between the two. And this makes it really simple to figure out what the independent variable is. It is whatever the hell you make your x-axis on your graph represent. It does get a bit more complicated though, because you rarely have just one predictor for your outcome, and you need to control for other factors. Take a study that I'm involved with as a side project. Now, we are looking at predictors for success at university. Now, one of the main predictors are high school grades, and another big one is sex, as in whether you are biologically male or female. Here we have our DV, which is university grades, and our IV, which is high school grades. However, sex is also an independent variable. Now, that is something that we definitely cannot manipulate, but it gets a little bit more complicated when you consider the fact that sex has an impact on high school grades as well. Girls outperform boys at school, but this gap widens when it comes to university. From this, we can conclude that the university attainment gap between the two sexes cannot be explained by female students just getting better results at high school. This results in an interaction. Not only do we have two independent variables which are needed to predict university outcomes, but one of the independent variables is dependent on the other. So what we have are called interacting variables, and we need to consider this interaction carefully. Now, in the lingo, we would call this controlling for sex. This is because that is not the relationship that we are investigating, but mathematically, we are just treating it as another independent variable. The actual complexity of the model is far understated here, as there are a very large number of factors involved in this particular study. But to get to full details, you have to wait for it to be published, and that's not going to be anytime soon, as no one actually works full-time on this project. Now, if I were to summarize all the above, I would say that the definition of the independent variable isn't as narrow or strict as the flat earth community tries to use. It is not something that you have to physically manipulate yourself directly. It is merely that quantity which provides the context for an observed change.